Good morning, children. Let us continue with the lesson energy in 8th standard physics. So, in my previous video, I have discussed about work done. Is it not? Concept of work done. So, what we have learnt in work done, work is said to be done if a force acting on a body causes displacement in the body. Okay. So, suppose a body is there, you apply some force on the body, then displacement must be there in the direction of the force. Then in such cases work is said to be done. Is it not? We have learned about the mathematical expression of work done. W is equal to F into S. Right? Now in this we have discussed even the standard units also. What is the standard unit of work done? Standard unit is Newton meter or Joule. And apart from this, we have even discussed when work done will be 0. So, work done can be 0 in two cases. One is if the displacement is 0, work done will be 0. In the second case, force and displacement must be acting at right angles to each other. Then also work done will be 0. Apart from that, we have solved some 3 problems also. I have given one problem for homework. I hope you have done that. Okay, so now let us discuss about energy in today's lesson. Now we know that energy exists in various forms, right? Which are the various forms of energy? Like I have light energy, heat energy, sound is also a form of energy, chemical energy, right? Then atomic energy. Then we have wind energy. All these are various forms of energy. And we have mechanical energy also. Now in this unit we are going to discuss about mechanical energy. Now mechanical energy is of 2 types. Which are those 2 types you see? Potential energy and then kinetic energy. So we have 2 types of mechanical energy, that is potential energy and kinetic energy. Now let us take up first potential energy. What do you mean by potential energy? What is the definition of potential energy? On what factors potential energy depends, and what is the mathematical expression and standard unit for potential energy, and also examples of potential energy. Now, so what is potential energy? It is the energy possessed by a body by virtue of its position. So, when a body is at rest, then the body will possess some type of energy in it, and that is called potential energy. For example, water stored in a dam. Then wound up spring of an alarm clock. Water stored in a dam, wound up spring of an alarm clock, a stone lying on the top of the roof. Like this. So always remember, the energy possessed by a body by virtue of its position means when the body is at rest or when the body is in stretched condition. See here, wound up spring of an alarm clock means what we will do, we will wind up the spring of the alarm clock during night times, and in the morning what happens to that spring? It will get unwinded. So when you wind the spring of the alarm clock, then energy will be stored in the spring as potential energy. Now water which is stored in a dam or a reservoir, that water is at rest, so that water will have some energy in it, that is called potential energy. So if you refer your textbook, you can come across various examples which are given in the lesson. See, the examples for potential energy. When we wind up the spring of an alarm clock, our muscular energy is stored in the spring. So, when you wind up the spring of an alarm clock, what is happening? You are using your muscular energy, and that muscular energy will be stored in the spring as potential energy. Understood? Then, in a toy pistol, the spring gets compressed and stores muscular energy. So, even if you take a pistol, the spring will get compressed and it will store potential energy. So, remember what is the definition of potential energy? Potential energy is the energy possessed by a body by virtue of its position. See, sometimes the body can be at a certain height also. The body can be at a certain height also from the ground level. So, now let us see about that. Consider an object. Consider an object at a height h. At a height h from the ground level. So this is the ground level. Okay. I am considering some object which is at a certain height h. Now this object or this body, okay, will have some potential energy, and that potential energy is called gravitational potential energy. What is that potential energy called? It is called gravitational potential energy. Okay. Now this body is under the influence of gravitational force, right? Because when the body is allowed to fall freely, then the body will reach the ground in certain time t. So the body, when it is at rest at a certain height from the ground, will possess some energy, potential energy only, because the body is at rest, and that potential energy is called gravitational potential energy. Suppose if you take a elastic rubber band. When you take a rubber band and stretch it, then what happens? There will be increase in the size of the rubber band. The rubber band will be in stretched condition, right? The rubber band will be in stretched condition, and hence this rubber band, which is in stretched condition, will also possess some type of energy, that is potential energy, and this potential energy is called elastic potential energy. Okay. So remember, in potential energy we have two types again. Which are those two types? One is gravitational potential energy and the other is elastic potential energy. So these are the two types of potential energies. Please make a note of this. Okay, now let me give the definitions of gravitational potential energy and the elastic potential energy. Please write down the definitions. The potential energy possessed by a body at a height h above the ground, the head edge above the ground is called gravitational potential energy. Understood? Then, what is elastic potential energy? The potential energy possessed by a body due to change in the configuration. Due to change in the configuration of the body is called elastic potential energy. Okay. So what examples we have to remember for gravitational potential energy? For gravitational potential energy, I told from the ground level, a body is at a certain height, right? This body will be at rest, but the body will possess some potential energy. It is called gravitational potential energy. If you take a spring or a rubber band and stretch it, then what happens? The size of the rubber band or spring will increase, means there is a change in the configuration, there is a change in the size and shape of the body. That is called configuration. If there is a change in the size and shape of the body, then we call it as change in the configuration. And due to this change in configuration, what type of potential energy will be stored? Elastic potential energy will be stored in the body. So, now what all I have taught you children? You have to remember about the definition of potential energy and the two types of potential energy. One is gravitational and the other is elastic potential energy. Please note the definitions. You can even refer the textbook for the definitions. Okay. So finally what we have learned, the energy stored in the body will depend on two factors. Which are those two factors? One is the distance or the height of the body from the ground level and change in the configuration. So now write down, potential energy depends on two factors. Which are those two factors? One is potential energy means what? Energy stored in the body depends on two factors. One is change in the position of the body. Change in the position of the body. Now change in the position of the body means what? I will tell you. See, this is ground level. First let us take the body is here at a height h1. I will call the height as h1. Now the body is at a height h1. At this position A, the body will possess some gravitational potential energy. Okay. Now, if the body is taken to a different height, say, I will take the body to a different height, that is h2. Now the body is at position B, then also the gravitational potential energy will be there for the body, but the potential energy at height h will be different. The potential energy at height h2 will be different. At height h1 it will be different, and at height h2 it will be different. The potential energy will not be the same, because you can observe here the height of the body is increasing. As the height of the body is increasing, the gravitational potential energy also increases. So, the more you take the body higher and higher, then the potential energy also increases. Okay. Now, what is the second factor? Change in the configuration of the body. So, if there is a change in the shape of the body, like a spring, see, this is a spring in compressed state. Now I will apply force here in this direction. Then what happens? The spring will be in stretched position, right? Now in such cases also there will be potential energy, which is called elastic potential energy, but because the configuration is changing, then potential energy also changes. So these are the two factors on which potential energy depends. Remember here, as the height increases, the potential energy also increases. So when the height changes, the potential energy changes. When the configuration changes, then also the potential energy will change. So this is about potential energy. Now let us come to the mathematical expression for potential energy. Write down these 2 points. Mathematical expression for potential energy. Now let us consider some body. Okay, it is on the ground, on the surface of the earth, and the body is having mass m. The body is having mass m. Now, already we know that the gravitational force will be acting towards the center of the earth. So, gravity is denoted by which letter? Small letter G. Gravity always acts towards the center of the earth. So, I am showing in this direction. This is direction of gravity. Now, this is the mass of the object or rock you can consider, which is present on the ground. Now, I want to lift this to a certain height, h. I want to lift this rock or object to a height h. Then what I should do? So, if you want to lift that one, then you have to do some work. That is simple. You have to do some work. So, some work has to be done to raise this object from the ground level. The mass of the object is m, and to what height you want to lift the object? You want to lift the object to a height h. Now remember, gravity always acts towards the center of the earth, right? Now, weight of the object is how much? Weight of the object is given by the product of mass and gravity. Weight of the object is given by the product of mass and gravity. So this object will have certain mass m and gravity is acting towards the center of the earth. So what will be the weight of the object? Weight of the object will be equal to mg. This is the weight of the object. Now, if you want to lift this object, then I told you have to do some work. It means you have to apply some force on the object, right? You have to apply some force on the object. And in which direction you have to apply the force? You have to apply the force in the opposite direction. You have to apply the force in the opposite direction to that of gravity. Gravity is acting towards the center of the earth. If you want to lift this rock, you have to apply some force against gravity. How much force you have to apply? The force applied must be equal to weight of the body. So, you have to apply force which is equal to weight of the body. Now, weight of the body I have written, that is given by the expression m into g. So, how much force you want to lift the object? How much force you have to apply to lift the object? How much force you have to apply? That is equal to weight of the body. So, I can write it as F is equal to mg. This much force has to be applied on the body to lift it. Now, through what height you want to lift the body? To a height h. So, when you are applying some force, then the body is displaced to a certain height h. In such cases, what happens? Work is said to be done. Now, so we can take work done is equal to F into S, right? That is equal to how much force we are applying? Mg. and through what distance I am lifting the object h. So how much you will get? mgh, right? This much work has to be done to lift the object. That work done to lift the object is called potential energy of the body. Okay, and what is the expression we are getting for potential energy? It is mgh. Okay, so once again I will come up with the derivation of potential energy. Mathematical expression for potential energy. Consider an object M and it is lying on the ground. Now gravity, in which direction it is acting? It is acting towards the center of the earth. And by what height I want to lift this object? I want to lift it to a height of h. Now always remember, what will be the weight of the body? The weight of the body is given by the expression mg. In lower classes we have learnt about this. In 7th standard, 6th standard, we have learnt about this expression. W is equal to mg. Now to lift the object, how much force I have to apply? I have to apply a force which is equal to weight of the body. And in which direction the force is to be applied? I have to apply force in the opposite direction, against the gravity. So that should be equal to the weight of the body. So I can write, therefore, F is equal to mg. Okay. Now W is equal to F into S by work done formula. Because I am applying force and the body is getting displaced. So work is said to be done here. So W is equal to F into S, that is equal to mg into h, which is equal to mgh. So this work done is nothing but potential energy, and what is the mathematical expression? It is equal to mgh. Okay. So remember, work done on this body will be equal to potential energy. It is given by the product of weight of the body and the height to which the body has to be raised. So finally what we can conclude? Potential energy is the product of weight of the body and the distance through which the body has to be raised. So this derivation is given in the textbook also. You can refer the textbook also for derivation. In the meanwhile, now you can note down this. This is the mathematical expression for potential energy. Okay, in the next video, we shall continue with the standard units for potential energy and examples of potential energy. Some more examples of potential energy and some problems we shall solve on potential energy. Thank you, children.